think we can probably go ahead and get started. For those of you who don't know me, my name is James Young. I work at Granular, which is the ag tech company with a booth right out there. We basically do everything that makes farmers more efficient at farming. We want to produce that software. And I'm going to basically take you through the history of Granular in the cloud today. I joined Granular about 2.5 years ago. That was really my first foray into cloud. Before that, I had worked at IBM, where I have the pleasure of saying I had root access on 250,000 machines. I did not know what DevOps was at that time. I actually didn't even hear the word until I left there, but we were basically doing deployments of up to 10,000 machines at a time there. So we were doing DevOps. And I later got the opportunity to come to Granular and make use of those skills. So if you don't know about us, like I said, we're all ag tech. So we do everything from accounting software to real estate acquisition, all the way to applications that we can basically take satellite imagery and tell you if your crops are healthy or not healthy. As we kind of go through this, just kind of some housekeeping stuff, you're going to see me toss around the terms product engineers and cloud engineers. And basically the only distinguishing difference is the kind of software that you work on. The theme of this is that if you are working with cloud, if you were used to be a sysadmin or you're a cloud engineer now, you're really a software engineer first. So this is just basically saying product engineers work on things we sell to farmers. Cloud engineers work on software that those people use in producing that. This is our stack. I'm not going to go through all of it. It's all the buzzwords, Terraform, CloudFormation, all of that. The one thing of note here is in the past 2.5 years, we've seen an exponential growth in the amount of software and the kind of software that we're producing. So 2.5 years ago, we were running like hundreds of jobs a week in our Jenkins server, all manually created, which we'll kind of get into that later on. Was not good. And today we're running about 7,700 builds. That may actually even have increased since we're in, I think, like 4 different continents right now. So before we get too deep into this and I kind of give you the history of Granular and what I wish we would have done differently, I do have a couple questions for the audience. How many here have been working in the cloud for like a year, less than a year? Raise your hand. Okay. How many have written libraries or tools that are used inside of your team on your cloud engineering, your sysadmin team? Okay. What about libraries or tools that are used by other product engineers or developers in your organization? Okay. If you've written those tools, how many are backed by a state system like S3, Dynamo, RDS? Show of hands. Not many? Cool. This will be a very useful presentation for you then. If you had all said yes, this would not be anything new. How many of you who work mainly with the cloud or support infrastructure wish your product engineers or developers knew more about it? Show of hands. Okay, cool. How many wish that your fellow cloud engineers knew more about the cloud? I do. I mean, and I manage a team. This is kind of what I'm trying to get out with this presentation. This is a quote from a talk called "There is No Talent Shortage" by Andrew Clay Schaefer. I highly recommend you check it out. But he basically talks about how we treat DevOps inside of our businesses and DevOps as a culture as opposed to just like a type of engineer, which is something that a few other people have hit on in their talks. He basically said you're building a software business or you're losing to somebody who is. So if your corporation doesn't embrace software as a primary means to serve customers, you probably won't be in business that longer. And if you're in a cloud engineering team, I would highly encourage you to replace the word business with team here. If your organization is growing in the cloud and your cloud engineering team or your infrastructure team, whatever you call it, isn't embracing creating software for your developers, there's a high chance that you're going to be replaced sometime in the future, either by cloud engineers who do want to create that software or by product engineers stepping up to that role. Basically, the whole theory is that you can buy software, so classic kind of like ops style stuff. We'll go buy a tool to do the thing for us, but you can't buy a few important things for your organization. So you can't buy communities of expertise. You can't just like build that knowledge by buying a tool. If you've ever had anybody ask you when you're going to deliver the DevOps, that's kind of what I'm talking about. That was a real thing that was said to me. You can't buy stability or reliability in your apps. You can't buy good practice. And you literally can't buy all the software to run you need to run your infrastructure. You got to build some of it. Another good quote, I won't read this one out, but basically what we should take away from this is that both product engineers or people who are product focused and cloud engineers have an increasingly broad set of things that we have to pay attention to. Some of the keynotes, the one this morning in particular, kind of drew out the crazy architecture that we follow with a lot of our applications. And when he drew that out, that scarily looks exactly like what we do. We put stuff into Jenkins, deploy it to like 10 different places, use a bunch of different cloud services, and it's all running on Kubernetes because that is the thing right now. So in this article, which I also recommend you take a look at, they basically talk about how do I share expertise across my organization? How do I take those like unicorn cloud engineers or even product engineers and share the knowledge or share the things that they're doing with others without having to kind of pull them away? And the theme is essentially you need to encapsulate knowledge in your software. We're going to get a little bit more into that, but I'm going to give you some background on what happens if you don't do this. This is essentially Granular's history in the cloud when I kind of started about 2.5 years ago. So 2.5 years ago, this is essentially what an application at Granular looked like. We had one Git repo in the bottom there that would have CloudFormation or a number of CloudFormation templates. We would have Python scripts that would execute those and probably do some other kind of random manual stuff in the cloud. And then we would have a separate repository for all of our app code. Then we would have a manually created Jenkins job, a lot of times like 2 or 3, one for each environment. Of course, manually created means they're all a little bit different, which we'll get into. That would take those, mash those repos together, and deploy something out into the cloud. And all in all, if you're small or you're new to the cloud, this is probably not a terribly unreliable thing. But if you've kind of been in this role before, you know this doesn't really scale. Because what happened is when we needed a new application, somebody thought, I'll just clone this and change the remote, and we'll just start kind of like building this thing of a bunch of different APIs. And I mean, it's even worse than this in real life, but you can see how just copying and pasting a lot of this stuff, manual jobs, led to some pretty bad things for our DevOps team. So if you've ever seen Multiplicity, that's kind of what we were dealing with. And if you haven't, basically the guy clones himself, the clones make clones, and they're really stupid. So some of our clone software had a lot of things bolted onto it that weren't really needed for that particular piece of software, and were pretty poorly understood. If you're a fan of Futurama, things kind of looked like this. I pulled this up today and I thought, a bunch of drunk robots doing random things. That actually sounds pretty close to where we were at the time. So we took a step back. We realized this is something that's probably not going to scale beyond 40 or 50 engineers, which is where we were then. So we basically said, okay, old accounts, those are just maintenance. We're not going to put anything new in them. We created new accounts. And then what we did is we created a GitLab repo for each AWS service we were going to interact with. So if you go into Git today, you'll see S3, IAM, RDS, Dynamo, so like 15 different repositories. Maybe some of you already know where this is going. What we would say is, all right, we want developers to own their stuff, so we want them to write their own CloudFormation, which is great. That's a good thing. And at the same time, what we said is these manual Jenkins jobs aren't going to work. So we basically embarked on a journey to translate 700 manually created jobs into DSL, Jenkins DSL, if you guys have ever used that, which is essentially automating the formation of your jobs. So this is what things look like. And on the surface, this doesn't seem too bad. It's certainly a lot more structured than what we had before. But this was kind of the problem. So there's a trust problem inside of our organization that we're actually still trying to fix today. Wherein we said, if you're touching the infrastructure, that's kind of like a high-risk thing. You might break other people's stuff. So we want like 2 cloud engineers to approve your merge requests. We have 150 at this time, probably 150 product engineers who we didn't trust, we decided, and like 8 cloud engineers. So you can imagine, just think about like a standard application that you have today, right? You might have like S3, you might have a Dynamo database. You might have a caching layer, like you needed to set up Elasticache. You probably have like IAM rules. You've got a compute option. You might have like 7 or 8 different AWS services that you need to coordinate to actually like make this thing run, right? So anytime you make a change to those, or when you want to start a new one up, take that times 2 approvals, and it's literally like in the neighborhood of 12 to 20 approvals you have to get from a small group of people in our organization that ended up being very time consuming. And it was great for us, but it was really bad for product, specifically for that reason. Like from a cloud perspective, we liked this because I got to know about everything that went into the cloud. We got to say what you could and you could not do. We got to basically inject ourselves into the product development process. It was good, but because everybody had to wait, it was really bad for our product teams. So at the end of the day, we really didn't recognize that the product teams delivering things to farmers was really what makes our business run. And we were being a gigantic bottleneck to that. And I believe software is kind of the solution. So this is where I would really like to be. This is typically how I would like to see things run in our organization in the future. And we're already making moves in that direction. So first, I'd like to see our cloud engineering team make applications for our engineers. We're already doing that. We're continuing to do that. But essentially, we're making that asynchronous to the process that developers follow to create applications. So we create APIs, libraries, software that will inject all of our governance rules and do checks against them when people deploy apps. So we can provide the developers with the same feedback that we would otherwise have to do manually. That's where I would like to see us go. And I'd basically like to see the product engineers unhampered or really non-dependent on us for a couple of reasons. First of all, to move fast. But second of all, I think that through software, we can address the trust component or trust problem that we had in our organization, where we were basically slapping developers on the hand anytime they wanted to do anything. So if we can do that fast, provide a fast feedback loop, our hope is that we can move faster and be safer. So retrospectively, 2.5 years ago when I came into Granular, there are a couple of basic premises that I wish I would have accepted, or I wish I would have thought of back then, that I think would have made this a lot easier. And especially if you're new to the cloud, I would encourage you to embrace these as well and kind of think about these as you're moving forward. Because it took us 2.5 years to do this, but I can actually tell you that all of the technology that we use today to accomplish this stuff was generally available like 2 years ago. Like CloudFormation is not new. Jenkins is not new. A lot of this stuff was around. So this was a non-technical problem that I'd like to solve with software. We just didn't realize that we could do that at the time. So first, accept that cloud engineering is software engineering. You might be in an organization where you used to run ops in a data center, or you're not used to writing software. But one thing that I think we have to accept, especially if we want our applications to actually scale in the cloud correctly, that is, serve as many customers without costing like 10 times as much, is to accept that a lot of the things that we do need to be accomplished through software. Servers could be blown away at any moment. AWS might tell you this isn't healthy. See you later. So you have to have some mechanism by which you can manage all of this stuff, and it can't be manually. Naturally, software automation, really important. Ipso facto, doesn't matter if you were a sysadmin or a software analyst, or if you were just some guy that they hired to click around in the console. It doesn't matter what you were before, managing things in a data center, or how you've run stuff before. You are an engineer of software that helps people use the cloud. Like, bottom line. Second, accept that if you're embarking on this journey, that it is going to be a learning experience. It's really intimidating for somebody from a classic ops background or somebody who's not familiar with either the cloud or software engineering to get into this. That's fine. I can tell you, this happened to me like at Granular. I managed to delete all of our SNS topics and all of our subscriptions and like half of our Dynamo tables in prod, which was not a great day for me. But basically the outcome of that is we discovered that bringing that stuff back because we had automation was actually much simpler. So like the key thing to take away here is even though it can be intimidating at first, the more automation that you build and the more maturity you build in this area is actually a kind of a key piece of covering yourself or reducing the risk to your environment. That's why if you've ever like looked at anything in terms of like CI/CD and pushing things to production, like small change, small risk, right? And then if you are in an organization where you aren't used to software engineering, I would basically leverage the expertise around you. One of the things that Granular kind of failed to do early in the cloud, in our experience with the cloud, was talk with other developers around us and talk with our product engineers and figure out, okay, what is it you actually want or need, or what is the real risk we're trying to cover? I think a lot of cloud engineering organizations make the mistake of overestimating the amount of risk in terms of what you allow developers to do, or vastly underestimating it, which is kind of like where we first were, where everybody had like admin and then the pendulum swung and nobody had admin. Next, you need to accept that the cloud will give you tools without direction. Jeff Bezos is not going to come to your office and tell you how to use AWS cloud services. It's just not going to happen. And even if he could, there are specific functions that your company is trying to perform to be successful in the marketplace that mean that there's like nothing you can buy off the shelf that's going to solve every problem for you. You can kind of get there, but not kind of all the way, right? Like we have a granular way of managing AWS and doing DevOps, but that doesn't necessarily translate to what your company needs to do. So when you think about how you want to run the cloud, again, the best way to encapsulate that is in software. Like culturally, how you interact with product engineers, especially at scale, sometimes needs to happen through software. Next, I know that a lot of engineers don't like to kind of think of things this way, but accept that your software is a product, right? Even if you're serving internal customers, the users of your product ultimately will basically tell you if it was a success or a failure. And every year when your manager comes to evaluate you and he sees that all the things that you made were maybe cool, but kind of like failed to make an impact, that kind of says things about how you're running that team. So you have to talk to them. And I know that if you're an engineer, again, we've had a lot of cases where they don't like to talk to other people, especially outside of their team. Like we all kind of naturally silo ourselves, right? One of the things that we've done recently to help us build software for product engineers is actually go and talk to them. So we've kind of embarked in the last like quarter or so on building some relationships with them and kind of starting to fix the trust problems that we had so that when we do deliver this software to them, they actually want to use it and actually accomplishes a goal for them and it makes their lives easier. So kind of accepting those premises, I'm going to give you just some examples on how we began to fix this cultural issue through the creation of software. First thing that we did is like not necessarily software, but plan well. I think if you're from a traditional ops background and you're used to everything being driven by either tickets or like really old school PMOs, it's really hard to embrace the concept of planning in a sprint or planning in the short term. We had for like a year and a half an agile board that had a bunch of stories on it that like nobody prioritized and nobody used, and they were about a sentence long. And we ended up just like tossing the entire thing out and just setting up like a general Kanban board in Jira and getting a Scrum Master and actually starting to do grooming. So if you're not doing any of that stuff before you embark down the software path, you need to. Otherwise, you're going to create a lot of things that nobody's going to use, and you're really not going to understand how they fit into your system. The other thing that I think a lot of ops people miss is the ideas of iteration and parallelism. You know, in kind of the old way of doing things, if you were SSHing onto a server and you're like executing bash one-liners, if you think about it, you're essentially writing the software at the same time you execute it, right? So you thought of a thing to run, you're modifying the system. That doesn't actually lend itself to iteration or parallelism. And you have to look at the cloud differently because the solutions that we have to provide as cloud engineers need to be applied in a repeated fashion. That's actually how you bring value to product engineers. So embracing a way or embracing some method of planning helps you start to understand how to work with the other people on your team to produce the right thing. The other thing that I kind of noticed before we started doing some of this is the concept of like unicorns. If you guys know what those are, like unicorn engineers. I like to call them special chickens. Like those engineers who are like really solid individual contributors in their own right that are just garbage at sharing things with other people. Like really bad. If you take just any like solid proven planning process and put it in place and then make those people work together, it's actually a really good way of breaking down silos. Next, dog fooding. I'm sure everybody's heard of this one before, but I think it's worth mentioning. Build tools inside of your team. Think of the things that you do on a daily basis that really kind of suck. Like you might be good at them, you might be bad at them, but you really don't want to do them. That would be kind of an early area where you can look to start writing some of this automation. You'll get pretty quick feedback from the other cloud engineers that you work with, and you'll be able to tell pretty rapidly if it's actually making a change. You can measure that. You could say, I want this to reduce page outs. I want us to be able to do more complex work. I want a lower ticket count, whatever it is. You should be able to get that feedback pretty quickly. And then if your company has a production readiness standard, follow it. If they don't, create your own. I think this is a space where people miss the opportunity to be their biggest critics. I think it's a really valuable thing when you're trying to think about how you serve others or how you can serve product teams or people on your team, is to put constraints upon yourself that are more rigid than anybody else in the company. An example of this is after we created our new accounts, it kind of came to our attention that all of our cloud engineers were using like an administrative level role all the time. Like we provided like 3 or 4 roles, admin like every time. So what we did is we set up CloudTrail to alert anybody or to create JIRA tickets and assign them to people who had used that. And we thought it wasn't going to be that big of an impact. And then like the day we turned it on, I got like 80 emails for JIRA tickets where I had used the admin role. And so we didn't realize how difficult it was for our developers to actually do anything before, because we always had God mode. So putting constraints upon yourself is a big part of dogfooding that I think a lot of people miss. Next, don't rewrite what's already been written. I know I said you can't buy software. That doesn't mean you shouldn't. You just can't buy it for everything. I think the 80-20 rule is something that I live pretty aggressively by. And I think picking up a piece of software like Terraform, for example, is going to provide like 80% of the technical things that you need to do, right? We brought Terraform in and we failed to put standards around it. And if you go and look in repos today, we're still cleaning up. There's like 10 different processes people use to apply the Terraform, and it's a giant headache. So when you bring in third-party tools, you're building software for them before you release them into the wild. Your environment's going to be a lot more repeatable, and you're going to have much better knowledge of how your developers are applying these things. I'll give you guys a couple examples, like specifically of what we did to improve how we were kind of running our DevOps or our cloud engineering model. The first one was getting rid of the manually created jobs. So like I said, we had a Jenkins server and it had like 700 manual jobs. So we would have like a dev job, a test job, and a prod job. And because they were manual and the environments were manual, they were all different. So I could never really guarantee that thing that we deployed in dev was truly the exact thing that we deployed in prod. And with that in place, we were encouraging a lot of bad practices. As we walk through this, you probably kind of see some things that we were doing that were bad because I'm calling them out. I wouldn't moralize these things. I would notice that they were going on, and we'll talk a little bit about this later. But people following bad practices can be a result not just of like a moral stance, like they maybe don't care about secrets. It can also just be the way that you've enabled them to do the job, right? If you need to get a feature out and you need to check an API key and get to do it, there are a lot of people who would do that to meet the milestone or try and deliver for the company. It's not great practice, but it doesn't make them a bad engineer. It maybe means that we haven't enabled them enough. So we had a lot of that going on. And just to give you an idea of the kind of tech debt you can build up when you don't embrace automation and software right away, we moved all these Jenkins jobs off like a year and a half ago, and we deleted the server last week. So that was sitting around as a manual resource that we were afraid to turn off because we had no idea what was going on it for 18 months. And for us, that wasn't necessarily costing us a lot of money, but those things kind of pile up over time where you have a lot of tech debt, especially if they were created by people who are no longer with the organization, which was the case, where you're afraid to turn off, right? And the cloud's all about creating cattle and not pets. This is what that lifecycle looked like for kind of a cloud engineer, because we owned all those jobs at the time. We'd make a change in Jenkins, we'd deploy it, and we'd be like, wow, I really hope that worked. Not only did we not have any health checks on our applications at that time, but the feedback from a lot of these jobs was just not great in general. So we were doing things like swallowing non-zero exit codes and just saying it was good to go. And a green ball in Jenkins didn't necessarily mean that the app was running. So it was really like a guessing game, and you have to do a lot to actually validate that what you just deployed was reasonably stable. So we, at the same time, thought about what's more distributed and what's more reliable, what's more repeatable. So in these new environments, what we ended up doing is first Jenkins DSL, which I'm not going to go into here because I think you all should just go and do pipelines today. But we went to Jenkins pipelines, which is essentially Groovy files. You check in with code. A couple benefits that we saw from that were that application engineers or product engineers owned how their applications were deployed. So a product engineer going into a repo could open this file and see, here are the steps that I take to deploy this application to 4 different regions and like 16 different Kubernetes clusters. And they get kind of an idea of how these things are being deployed. Secondly, we kind of got some revision history around that. So if you made a change to the pipeline, you needed to revert it, you could do that. Before, it was like you click save in the Jenkins interface and kind of hope that you didn't need to go back. Or you like copy and pasted it out and put it in Get It or something like that, just in case. And then what we also set up at the same time was a merge bot. So again, kind of on the lines of using software to allow us to trust more in our environment. We basically allowed this merge bot to just auto merge additions of new pipelines. So if you need to set up a new application, whereas before it was like 12 different merge requests, that burden is reduced at least slightly with this. And that's a pattern that we're trying to follow with all of our infrastructure that we're implementing right now, is how do I determine when a change that they're going to make is really risky enough that I really need to see it. Like maybe the application team should be the only one approving changes to their RDS instance because they can only bring themselves down. So a lot of things in our organization are moving in that direction. And that pipeline actually looks a lot more like this today. So app code, Jenkins file, all in Git. Jenkins knows where to find it. He'll check it out and validate that that's syntactically correct. And if it is, then you can kind of use it however you want. But if not, you get the feedback within like minutes. So as before, what we would have to do is manually make a change, make sure the application deployed, get an application or product engineer to smoke test that, actually go and make sure that it's running how it should run, and then probably make a change again because we probably messed something up. You get immediate feedback on whether or not your pipeline's even correct. Once you kind of start to do some of that stuff, you should start identifying patterns outside of the team and solving for them. So if you're not really familiar with software engineering and you don't know the concept of dry, it's don't repeat yourself, this was a big one for us because we had been basically copying and pasting and tweaking Python scripts to apply all this CloudFormation as opposed to using like a standard library or a method for applying them. So if you find that stuff, that's prime for automation. And again, a huge component of this is not just writing software, but actually talking to your audience. So you should think about your cloud engineering team in terms of like an actual product team that has a scrum master, that has a product owner or a product manager that will actually go out there and work with product engineers to collect the feedback on what you're creating. And this is another example of kind of how we did that. This is that unique CloudFormation. So in the right top right-hand corner is kind of how we used to do it. We'd write CloudFormation, tweak it a little bit for dev, tweak it a little bit for test, tweak it a little bit for prod, check all three into the repo, which is terrible practice. Don't do that. And then we would deploy them and just like cross our fingers. What we ended up doing was just creating a library that would provide parameters to this CloudFormation. So you could write it agnostic to the area that you were going to apply it, provide those parameters in like an endless type file where we'd have a dev, test, and prod environment, and then let them apply. And that in combination with the things like limiting who has admin access and limiting what you're actually able to do in those higher environments is probably one of the most important things that you can do for success in the cloud. Because if you're not able to automatically deploy to test, that's pretty good feedback that that thing shouldn't ever be customer facing or it shouldn't go to production. Another thing that you can do is structure your software for easy understanding. One of the things, again, from I think the keynote today that we took away was that these systems are so large that it's nearly impossible for a single product engineer to understand what's going on. And it's really complicated the way that we make architectural decisions. But I think that cloud engineers can take a important role in helping to kind of fix that problem. So one of the things that we're trying to do too is structure our software for easy understanding. So think about this heuristically. If you're looking at a repository as a product engineer or a cloud engineer, the goal would be to be able to tell what does this application do, how is it deployed, what infrastructure does it use, and why is it important. Surprisingly, missing a lot in a lot of repositories I've seen both inside of our company and outside. And this is kind of reflected in the old way that we used to do stuff, right? If my application had S3, EC2, RDS, and Dynamo, that's 4 repositories you have to go to actually understand how this application works. So when we're kind of creating software patterns for our product engineers to follow, ease of use is something that we should definitely consider. And if you don't believe me, just remember that when product engineers run into issues with the cloud or with their application pertaining to infrastructure, you're the first person that they're going to come to for help. So if you're not interested in answering what you consider to be, but might not be simple questions all day, or explaining infrastructure to people, providing a method for product engineers and developers to understand their apps better should be a top priority for you. So another example of that, we use Kong. If you don't use Kong, it's an API gateway built on top of Nginx. It comes with a nice API that you can just post routes to, and it'll update and front all of your stuff. So we front S3, Lambda, Kubernetes, all that cool stuff with it. But we also ran that as a kind of a monolithic repo. So it looked like this. We had like this big route repo with a bunch of JSON or YAML in it. And then we would require cloud engineers to approve that, right? Routes in and of themselves are not a difficult thing to fix if you get them wrong. Like you can just replace the route and move on with your day. So the risk that we perceived may not have actually been here with Kong. So what we ended up doing was creating like a Python library. And that Python library just hit a Lambda with a Dynamo table. And the Lambda would store all those routes in Dynamo so we could easily recreate our Kong backend or Kong database if we needed to. And it also provided some governance. So before, when we were kind of trying to review these routes for how much quote unquote risk they introduced, we basically just delegated that to the Lambda. If you're doing a lot of like reviews for risk in cloud engineering, you should ask yourself if that is a rubber stamp or if that is a case where you are actually reducing risk. Because I can probably tell you that any single person reviewing this repository took a look at the routes and rubber stamped it and went on. And nobody checked to see, do these routes conflict with other routes on other applications? Are there unsupported plugins? Are there X, Y, and Z? And we're actually able to build all that governance in when we delegate that activity to applications that we've created for use by our developers. So a quick recap. Fail early, fail automatically. Automatic feedback is always better than manual feedback. I would rather find out that an application is broken because of automation 5 minutes after I deployed it than to manually deploy it and find out 12 hours later that we've been down for quite a long time. It also lets people execute without feeling neurotic. I can tell you that there are applications that are sitting out there from the olden days that every time you go and click the deploy button on, you're just kind of like praying that it works. With any of the stuff that we have today, I know I can walk into most of the repositories. I can hit the deploy button. They're all idempotent, so it's just going to deploy the same version if it's already been built and not really have to worry about it. Because we've built software around how we deploy and how we kind of check the health of these applications, that's not actually a problem for us anymore. To the point where when I get paged out, it's usually not an issue with our system. It's a tuning thing that we have to do with the thing that paged me out. The next thing I would do is identify the way that you guys want to do cloud inside of your company. I've given you a couple of examples. They may or may not work for you. You don't have to take them. And in fact, I wouldn't take them without kind of like fully understanding what they did for us. So definitely ask me questions if you want. But working with product engineers to understand what they need and what problems they have in the cloud is key to actually creating effective software for them. Next, modern apps are huge. Like they span like tons of different systems. We run like probably thousands of different Kubernetes containers and use most of the AWS services that are common. So it's really difficult to tell across all of those services what comprises a single application. So keep that in mind. And then knowing your customer. One of the things, again, that we did wrong in Granular was kind of like moralizing the decisions made by others. Like, I can't believe this guy checked a key into Git again. He's such an idiot. And I'm as guilty of that as anybody else. But the reality is that nobody wants to make the decisions that will make your application less secure, less stable, or less reliable. They're making a pragmatic decision based upon the avenues that you give them. So the better that your software is that you produce for developers, the less likely they are to make what you might call like suboptimal decisions. Lastly, when you do make software, really easy to use and understand. Clear documentation, logging, and then get your product engineers to commit to that stuff. On a lot of occasions when I've gone out and talked to our product engineers on why they don't actually commit to our software, it's because I think we don't want them to do that. They're under the assumption that we want to safeguard all of that and we don't trust them to make changes. So again, something that we're still changing, but something you should look out for in your org. I also kind of get the pushback from inside of cloud engineering sometimes that, well, you want to understand one of our tools, you should read the code. So we're not going to make readmes or documentation, and we're not really going to log that well. And that's all wrong. I think it's important to ask yourself why everybody who drives a car isn't a mechanic. because not everybody wants to soup up their car. Not everybody wants to go take it on the drag strip. Some people just want to get from point A to point B. So allowing your software to be a mechanism through which they can do that is more important than insisting that everybody read every piece of code that you create to understand what it's doing. And then lastly, when you're thinking about this stuff, you always have to prepare yourself for the next level of scale that you're going to achieve. When I started at Granular, we were like 100 people. Today we have 290 product engineers. We have 20 cloud engineers. So we've grown quite a bit, and we're definitely not stopping. We just went to 4 new AWS regions, so someday this strategy might fall apart. Certainly, we couldn't run things the same way today as we did 2.5 years ago. Our systems would be completely hosed. So when you're thinking about this stuff, always think about the next step. And that's all I had. If there are any questions or anything like that, definitely let me know. And just so you guys know, I am looking for cloud engineers on my team right now. So if you like cloud and you like Python, hit me up. Cool.